The word synthesis means combining parts to make a whole that's more than the sum of the parts. In the case of tonal synthesis, this means manipulating the four parameters of sound to create a new tone. Now, in the early days of synthesis, music synthesis, tonal synthesis, we used voltage-controlled synthesizers. That means that applying a different voltage would create a different note or would create a different amplitude, that type of thing. Nowadays, almost all synthesizers are digital, which means basically that they have numerical control. If we wanted to create one, we'd have to use a certain number of basic circuits, and all synthesizers use some type of these circuits. Okay, let's start with a basic shell here, and inside that shell we'll put a keyboard, but at this point the keyboard doesn't make any sound. Why? Because we need a digitally controlled oscillator. This is the thing that creates the numbers which numerically measure a waveform, and then we can actually get a sound. Now, it's not a very interesting sound, so another function of the DCO, besides providing a frequency, is to provide a different type of waveform. So sometimes you might have that sawtooth wave, sometimes a sine wave, other times you might have different waves of different types. Now, it's still pretty boring, even if you create a sawtooth wave or some complicated wave. What we need to do is shape that wave over time, and that's the function of another circuit called the DCA, the digitally controlled amplifier circuit. In this, if we apply it, we get a different shape to the sound, a different envelope. Okay, that's a little more interesting. Now let's try shaping the waveform over time, because sounds change in timbre over the course of time that they're playing. In this case, let's change it so that it starts as a sawtooth wave and ends as a square wave. Okay, so far we've got the three basic circuits of a synthesizer: a digitally controlled oscillator that creates the frequency and the waveform, a digitally controlled amplifier that changes the amplitude of the waveform over time, and the digitally controlled waveform modulator that actually controls the complexity of the waveform over time. We can add a few more circuits to this, like the LFO. That stands for low frequency oscillator, and basically just adds a vibrato to the tone. Finally, we can add some effects. In modern synthesizers, you can usually add some reverb or echo effects. In this case, we're just going to add a little bit of smoothness to the sound. What we did there was take out some of the edginess of the tone by using a low-pass filter. And that's basically how all modern synthesizers are created. Now, the DCO is a little more complicated than that, and we're about to describe some of the different types of synthesis that apply to the DCO. Additive synthesis, subtractive synthesis, FM synthesis, wavetable sampling, granular synthesis, and phase distortion. We'll show you those in just a minute.